Okay, I'm gonna try to get a little video in here for week 7. Uh, Let me get my screens set up here right quick. Like, no, it's not what we want. There we go. We're getting there. We're getting there. We're getting there. Okay, so this is earthwork analysis basics. It's a traditional calculation method. There will be two methods within this traditional calculation. It's old school stuff. The idea in estimating is to find out how much dirt you're going to be moving. And going to talk about how we're going to do that. This will this is giving us a little taste of what we'll be doing in our estimating course, which should be coming around. I'm not sure what date it is, but let's just start off talking, and I think things will become clear. Uh, there's a lot to talk about here. That's maybe 15 slides. I don't know, but that's probably all we're going to cover right now. More things you'll find probably in the week 7 module. So the first thing, it's the module is let's get it on slideshow. Let's get it on slideshow from the beginning. Okay. So this really is taken from another course that a full course. I just kind of grabbed these snippets from the course uh, because I didn't want to. We don't have time to go through a full course of uh, this specific part of it. I'm having trouble getting going here. Anyway, uh, so this slide one, it is what it is. Now, the objective for you guys is to show me or to show yourselves that you have knowledge of some terms that we'll be going through. And when we're performing a cut and fill analysis using the grid method, there are other ways to do this. And you'll be able to I would like for you to demonstrate, and we're going to do the best we can to see how this does. This requires a lot of tables, pictures, and things like that. But I think I have it pretty well figured out how we can assess ourselves, and I can assess, uh, grade wise. So the averaging, here's the two grid method by both of these. Averaging the quadrant elevations. Now, what is a quadrant? A quadrant is an area within a square, a rectangle, let me say. It doesn't have to be a square. That's what a quadrant is. So it's going to have 4 corners. Now, going back to a grid, at each of these corners, they will be touching another corner of another square within the grid. And you go on and on and on. So you will take the elevations at each of these corners of these squares that are adjacent to each other. You will take the existing grid and compare that to the quadrant elevations of the proposed grid. Now, that's one way of doing it, and this is another one. And these are really kind of overlapping, and to me, as I went through this, trying to see the differences in this. So the first one, we're going to average the quadrant elevations. Not so much talking about these corners, which we will get into in item B here. The other method is averaging the difference of the node elevations. A node is the intersection of a row or column in a grid. So that's the corners where, they would touch each other, let's say where the grid intersects. So uh, they will have, we will figure out the proposed elevation at these corners, and we will calculate, or interpolate's going to be another word. It's kind of like a guesstimation, because contours existing and proposed are not always right there on these nodes, so on these corners. So we're going to have to what's called interpolate. Now we can do that with a ruler. Now I can't do it on the slideshow here, but we will guesstimate it, and I'll show you how we're doing that. And but there are ways where you can develop your scale, and down the road we will get into that. But for now, let's move on to a grade plan. And everybody may or may not have ever seen a real grade plan. Now, this is more of an instructional grade plan we're going to look at uh, in just a minute. So it says when preparing to perform an earthwork, sorry, I have to read these. There's nothing else I got to say. I don't have notes yet, my own notes. When preparing to perform and that's supposed to be an earthwork analysis of a site, the engineer must first be provided with the document that defines the existing conditions, that's existing contours, including the topography. So that would be your I'm sorry, that would be your existing conditions right now. Now, if the survey, it's a topographic survey. What is it like today? You know, when you do a site, you're going to be paid on the difference of the dirt you move between the way it was when we took this survey, and then when you complete the site prep or the earthwork, there'll be another topographic survey. Usually the contractor may do it to make sure that it gets done, because they're going to pay you so much per cubic yard. So you want to be sure, and you can do this by an initial uh, survey and then a post survey, let's call it. So if the survey is received with adequate information for the purposes of regrading, I'm not sure about that term, but for the purposes of grading, it never has been graded, uh, a site by design. And by design would mean, like, after you get the proposed elevation and the building pad where it's located, you get the uh, finished floors, the footprint of where the building's going to be. So it will identify the existing surface features. It will have some, those will be contour lines. It will have some spot elevations and both existing and proposed contour lines most of the time. Sometimes they just don't need them both. And we won't see that today, because we're talking about proposing existing grades all through this PowerPoint. The following slides will describe the process of site work analysis. We'll need to draw or overlay a grid scaled to the needs of the grading plan. Now, what in the world do I mean by that? Now, you can be reading this PowerPoint. I'm just reading some notes I made. So we're going to take uh, the existing grade, and we're going to overlay, or the the grade plan, I'm sorry, that has the existing contours and the proposed contours over it, and we're either going to draw or overlay a grid, like used to they use transparent paper, and with a grid on it, and it says scale to meet the needs of the grading plan. Uh, right here needs to set up a grid over the topographic plan of the existing proposed grade. So what it means by scale to meet to the needs of the grading plan is, you know, like the closer your grid is, or the tighter your grid is, the more accurate your takeoff is going to be, the more accurate your differences in these elevations of existing and proposed grade at these corners of the grid. The closer the grid squares, and we'll be working with one for sure is, and I think maybe all of them, but one may be 100, but it'll tell us, and one may be at 200 grid. So that means that that square, each square is 200 feet by 200 feet. And guess what? When we get the corners of that, the corners of the existing versus the difference between existing and proposed, we get that average of that, and that's going to give us either our depth in the form of a cut or a fill. So guess what? We have an area. If we have 200-foot grid set up, we have an area of 200 times 200, and then we'll multiply that by that net cut or fill that we come up with in our node analysis. So keep it moving here. So a little bit about units and a very little bit when discussing earthwork. The analysis must determine the volume of material being moved. In general, in the United States, the standard imperial SI units of measure are used. Many other parts of the world use metrics, and the SI units of volume, cubic inches, are cubic inches, which can be expressed in either of those ways there, and cubic feet, and either CF or feet to the third cube. And a cubic yard consists of 27 cubic feet. So everything will be measured in feet, and we'll come up with cubic feet, and then we'll divide that by 27 to get our cubic yards. It'll be a matter of averaging the differences that are at each corner between proposed and existing. That's our depth. And then multiplying length times width of the grid itself. And I think in our cases, it's going to be 200 times 200. And then that'll be our square footage. And then we'll multiply that times the depth. And then we'll divide that by 27. And we should come up with our net either cubic yard cut or fill. Okay. The next slide coming up shows an example of an existing topography that's like nothing's been done. We're going to overlay that with proposed topography and a grid over that. So we're going to have, this is our beginning right here. Let's look at this for just a second. Two hills, right away we can see that. Elevation, look, here is a, I call them draws, valleys, arroyos, or just a ditch, but the water's going to drain. You remember the V's are pointing uphill, so it's, and you can tell it's 105 here, and I think it's 106 here, so it gets lower as you go down, so the water's going to run this way. Over here is another place where water's going to drain because it goes all the way down. It starts up here 107, 106, 105, 104, so that water's going to run down there. And, you know, when you start thinking about this, I may have talk about it more in a different slide, but when you look at this, how are we going to get in here to get started working? Well, maybe up here where it's 105, but it goes up pretty steep. You know, you may have to do some work to even get on the site. Maybe we could come in through here, but all of this goes up pretty quick. That's a little bit flat, and it's kind of not much going on out here. But we'll be cutting off the top of these hills probably, and filling in these low spots with that to get the. We want the site to drain, but we don't want a arroyo or running water. You know, all the rate of flow. We want to slow it down, and we do that by raising these elevations. So this is the first thing that we see. This is the existing grade. Now, this is not a real topographic view of terrain. This is something that somebody drew so we could work with it. And here's the hill, goes from 108, 107. This in here is called a saddle. For your information, I think this is 105 going on out. 103 will come into play later, and it's going to be hard to find where it is, but we're going to guess on that one. So this is where we're starting right now. So let's take this and let's put some maybe proposed grades on it. There we go. All right. Now we still have the same existing grade, the dashed lines. That nothing has changed there, but we've included now the proposed grades. See this right here? This whole thing, this big square is set at 106 feet, and that is a contour. Now, probably if you look down here, this 107 probably is going to be where they will put a building pad, perhaps. This probably is going to be a parking area up in here, but we'll be using all the existing dirt, which we'll get into later on, to fill in the low spots. So we'll try to balance this out with that. And it may be, kind of looks like it might be balanced. So let me read a little bit of my notes here, just looking at this first shot. Figure F6, is that what we're looking at? Yeah. Shows an example of a proposed grading design overlaying the existing contours associated with the site we're looking at. The 107 feet contour could be a building pad. I just talked about that. A site access could be provided up here, maybe, coming in through here. Have to visit the site before we make those decisions. Upper right hand entry crossing the 105 and 106. Then we looked at the V-shaped contours for, we're going to have some pretty high flow rates going down there, so we'll level that up. And there's not much to add to what I've already said. Let's see, the building pad, perhaps, I'm not sure, but that's just my guess when I look at this, that they wanted that contour in here, and it's 107. So I'm gonna shift gears on you right quick before I move any further. I'm gonna talk to you about interpolating. So, well, let's don't do it now. Let's wait, because I think the next slide we're going to get a grid. Once we get a grid, then we'll worry about interpolated, and I think there it is. Okay. Now, somewhere in here, if I recall, it says that that the grids on this are 200 foot, and if I don't know how well you can see this grid from your computer, but my little arrow is at a node, an intersection of the grid right now. And if you look at C and you look at B and you look at D, these are all letters from the alphabet. Now look down here, 1, 2, these are numbers. So if you look at C here and you go out to the left, I'm hoping you can follow that, and you get to this intersection right here, and there's a 4 down here, and there's a C here. So this point, it would be called node C4. Okay, we got that. That's how to read this grid. This location right here at the intersection is C4. Now, look up here. We want to define this square right here. So we know that the corner is C, what did I say, 4? Yeah. So let's define this area in here. It's going to be called BC, talking about this area, BC, and then it will be 3, 4. It'll be called BC 3, 4. That's the quadrant in here. BC, BC 3, 3, 4. I'm sure hoping you can see this. And if not, I'm not going to be hard on grading this. There'll be some things, but that's a quadrant, and that's how they're defined. If you want to look at another one, let's just take the one. That's that one. That's BC 3, 4. That's this quadrant right here. And it kind of encompasses the saddle. So let's pause right now and let's talk about interpolating. Notice if I'm going to get the existing and proposed grade of this corner, I'm going to have, there's no contour line there. Now it's really close to an existing grade, which is 107. So it's really close to that. But let's take this existing grade of 106 and let's look at how far it is over here to 107. So if I go from here halfway, and this is guessing, you know, that's over halfway right there at the corner. But that's what I want. So this would be 106.5. So this right here would probably be 106 point, if this was 0.5, this would probably be 106.75, maybe something like that. But that's what I mean. So that would be the existing contour, and it might be 0.65. It depends on how accurate you're doing this. But it's going to not be 106, and it's not going to be 107. It's going to be 106 point. I'm saying 6.5. That's my guess because here's 0.5 halfway between these two existing. So that would be existing grade 106.65. Now, for the proposed grade right here, now we got to stretch out to, this is not 108, this is the 107 grade right here. It's kind of got thin on us, but this is 107 and this is 106. Let's go halfway from 106 to 107. I would say we're about right here. For proposed grade, to me, this would probably be one. Gosh, that's really close to halfway. So it'd probably be 106.5, something like that. It may, you know, give or take. It's a little bit closer to the 107 than it is the 106. So, but I'm going to say that would be 106.5. And these are educated guesses now, what we're doing here for sure. But as I said before, using a ruler, we could measure that and we could come up with a scale. And that we won't go into that right now, but it would be our scale for this plan. And we could get a lot more accurate using a ruler. But this is just for instructional purposes right now. But I will show you how to use that ruler to set yourself, we'd call it a scale factor. And I'm not going to get into it right now because we've got a lot to cover. But so that's the way we're going to find existing and proposed for these quadrants. You go up here and just to guess, to get an existing grade at this guy right here, you look at this. Oh gosh, this will be a kind of a hard one to get this one. But look at 104, how close it is to that. So 104, 105, gosh, I think 104.5 or 105. I'm sorry, 104.5, probably somewhere in there would take care of this for existing and back again to the 106 and the 107. So this would be 106.25, probably somewhere in there, 106.25 to get this grade right here. And again, that's just a close guess, but I bet I won't be too far off. There are some in here that are already marked for us that may be a little bit closer, uh, but that's interpolate. So now, we started out with the existing topography, and we put our proposed contours over our existing contours, and then we put a grid over that. And it's composed of quadrants, which are defined by either like B4 or C4 would be this and on the way we're doing this, if we want this quadrant, it would be C4. It would, I'm sorry, it would be B, C, and then C4. I think would cover that quadrant right here, because what we're wanting to do is find these two length and width for this quadrant, because we're using the 3 and the 4 here, like C3 right there, C4 right there, and then BC right there. That defines two sides of that quadrant right there. So there it is highlighted, the one we've been talking about. Perhaps you can see that better. But again, let me go over this it's got them labeled. Here's node C4 right here at this corner. C4. Up here is B4, this corner. There's B and there's 4 at this corner. Look over here, that's B3. And the reason it's B3 is because here's your B and here's your 3. So that takes care of this. And here's C3. We've already talked about that. But we have this quadrant, and when we have a whole quadrant defined, we will call it like BC, as this is, slash 3, 4, as this is. Quadrant BC 3, 4, node B3, node C3, node C4, node B4. Okay, let's move on. The first set of calculations that we'll come to, and we can look at what they think, and as opposed to we think, when we're looking at these existing grade. And what we're looking for is node B3. Let's start with that one. They're saying 103.95. Well, let's see, this up in here is kind of hard to define. Let's find, I lost the B's. Where's my letters? Don't I get a, how can I do that? Anyway, we're going to count on them, because I don't want to go flipping all over the place to find the grid since we're here. So they're going to say this, that we went through defining these. This is V3. Look what they have for V3. I don't know if you can read this, but they have existing elevation 103.95, almost 104, where the existing is. So I don't have an argument with that. Proposed right here, they have 106.25. That I can live with that, because halfway is between 106, that's 106. You follow it around over here, you'll see halfway between 106 and 107. This proposed, that's an existing 107. This is proposed 107, is probably somewhere in this neighborhood here, halfway between here and here. It's out in here somewhere. So they're saying it's 106.25. I can't argue that. 106.5 would be out in here somewhere. They're just saying that's 25. They're calling that 106.25 right here. So that's okay. So we've got node B3 existing 103.95. Let me go back and look at that and see where they may have got that from. 103.95 existing. Yeah, that's 104. So they said, wow, almost 10. There's 104 coming up around there. So they're calling it 103.95. That's good enough for me. Okay, so proposed grade 106.25, existing grade. Now, The book's going to say different, but I'm going to argue with the book a little bit. So remember when we first started, wait, let me go over this a little bit better. Maybe if I read from my notes just a minute so I can be a little bit clear here on this slide. The values defined in the table, that's this table here. The values defined in this table can be reflected on the plan, but usually the engineer marks up the plan and then transfers the information to a table, such as this. Actually, it's a spreadsheet, and he's got all of these formulas in there that calculates these existing versus proposed. So, and figure 9 shows the elevations as interpolated. And that's these elevations that we're talking about here, all over here, and ended up here. So in the table above, averaging the existing grades of, now this is me doing this, averaging the existing, in the table above, averaging the existing grades of nodes B3, B4, C3, and C4. That's the ones, the existing grades. That's right here. B3 existing 103.95, B4 existing 109, C3 108, 106. So I'm going to average these right here. So if I do, I what I came up with was 427.75. Now listen, you don't have to write this down or remember it because we're going back over it. I want to average these and come up with I would total them and then come up with the average. Well, the average, I don't think it's on the, yeah, there it is. So I'm doing this, I'm averaging it. I'm just going to cheat and skip on over there right quick because I came up with 427.75 for the total, and I divided that by 4. So I came up with an average of 106.94 for the existing grades. And if I go over here, they got 106.94 here. And then on the proposed grades, what did I get? 106.51. Did I get that? Let's look and see what they got. And that's what they got when they averaged the proposed grades. I was looking at my calculations; they're a little bit different, but I don't think so. Let's see. So do this. This is the average of the existing grades of node B3, B4, C3, and C4, right? This is the total. This is their average. So that's the average existing. This is the average of the same corners, 4 corners here. So it's 106.51. Now listen, if I take 106.94, or I'm going to call it, and I subtract the proposed 106.51, it's going to be a net cut, because it's going to be positive, of 0.43. Now they're not showing it here because I'm a little ahead of them in my notes here. So you got that? I took the average of the nodes, the 4 nodes for existing, totaled it, divided it by 4, came up with this. This is the average existing grade for that quadrant at the nodes, so the nodes of that quadrant. This is the total for the proposed, and this is an average. So take 106. Always do it this way. I always subtract the proposed grade from the existing grade. The book doesn't say that, and sometimes it doesn't do that. But if you do that, if you always take existing minus proposed, if you come up with a minus, it's a fill. If you come up with a positive, it's a cut. And that's important because when you get into working through these ordinance, that's what they'll be called when you get into your real takeoffs. They're going to have the cuts will be added, the fills will be negative, the cuts will be positive, the fills will be negative, and we'll may get to do a little bit of that. Maybe I don't know, week 8 or something, but. Hope everybody, by the way, got the dates on the in-person training. If you have questions, please give me a call or email or something to that effect. So this is where we were, and this was their interpolating stuff. But we got a little bit closer, we think, here, and they're trying to show you like a 3D of this cut that we have. Here's proposed blue, and I'm not sure what color that is, but it's average existing 106.91, and that's pretty close to what we got back, very close. And for proposed, they got 106.51. So I think we can live with that. 51991, that's close. Hundredths or two off. So that's pretty good. But this is like that quadrant we were talking about. Now remember, we now have length, width, and depth. So do I have any more about that? So just moving on with this thought, and then we'll do it again. The area of the quadrant, this area right here, is 200 by 200. And if you multiply that, you're going to get 40,000 square feet of space right here. That's your area. Now go back to get length and width times each other. It gives you area, 40,000 square feet. Now then, the depth, 0.43, as we determined a while ago by this minus that. We came up, wasn't that where we got that? I think, yes, 0.43. Now then, we take the 40,000, take the 40,000 and let me find it again. Multiply that by 0.43. That equals 17,200 cubic feet. Divide that by 27, and you get 637 cubic yards. Now, we're going to flip this guy. Let's see, where's my channel changer? And there it is, kind of worked out for us. There's that 0.43, there's that 200 by 200, there's that 17.2, and that was divided by 27 to get 637 cubic yards. And I forgot, that's what I got, actually, this time. Now, I'm going to continue on here. May have to get me a drink of water. I'm running out of moisture. What did I just do? Oh, I'm not ready to do that. So we did the existing grade from the proposed. Let's see. Ding, ding, ding. Next up, I may be getting ahead of myself. We'll see what the slide here says. I don't have a pause. And drink of water. What's coming up? Have we been here? No, that's the solution. The earthwork calculations for BC3-4 under the method 2 is developed in problem 3. So this is method 2, which, as you can see, is, I don't think, going to be a whole lot of difference, but they have taken, remember we dealt with this a little bit different in 1. We totaled these up and got an average first, right? Now, what they're doing is taking each node, existing minus this. That leaves, take 103.9. I think they did this backwards, and that bothers me that it's done backwards. So if you're looking at this, if you did it the way I suggested, which is the right way, and not to say that the book wasn't written by an engineer and maybe there's some flaw in my theory, but I always use 103 minus, I'm sorry, 103.95 minus proposed. This would be the same value, but it would be a negative. We'll go with what they said. They since it's a positive, I'm assuming they subtracted existing from proposed. So that's 106 minus this same value. It's a positive, which is a huge difference when you have positive versus negative. This means it's a cut. This here, they're saying it's a fill. When uh, if we were doing it uh, my way, this would be a cut. Now, we're going to come up with this figure right here, but if we do it my way, it's going to tell you this won't be a negative. As you can see down here, they have it as a negative. But just remember, the only difference they did, and they probably know what they're doing. You know, it's just that I don't like saying something's a negative because of the fact if it's negative, it's always been a fill, and that's what I'm used to. And you will have to do it as a, if you'll have to identify what you will have to identify whether it's a fill or a cut from now on. And the best way to tell is you can look at this booger right here and see that this proposed grade is higher than this grade, right? So what does that tell you? It's a cut, right? I mean, you can look at it. If you went my way, it would show up as a fill. And honestly, if this is existing and this is proposed, to get it to this thing, I'm going to have to fill, right? I don't care what it says. It's indicating cut because of this. But if this is existing and this is proposed, it's obviously a fill. I don't, it just beats me why they would put out something like this. I'll get off my soapbox. I hope you see that just by looking at it. Look at this. What's that? Just by looking at it. Existing is higher than this. So what is this? It's going to be a fill. They're calling it a negative. And if they like to live this way, I can come down here and multiply this times -1 and I can get it to say what I want it to say. But if you do existing minus proposed, it's going to tell you by the, what do you call minuses and pluses, whatever that is. It's going to tell you if it cut. This would be like it was on my other one, 0.43. Uh, this is why, because I took these same numbers, came up with this, but mine was positive when I did it. And so uh, they say average change in elevation of minus 0.425 across its four nodes. That means these four guys. And so they went through the same exact formula, and they're saying 630 uh, cubic yards instead of 37. I'm sorry, they're saying a negative 629.63, which is 630. So they're calling it 630. So it's close. We could banter back and forth over this, but I just have always done it existing minus proposed, and then this right here. Only thing is, and that's all random, is learning how to. And for me, I don't know why, but it's always been a problem to add these up because this is addition here, and I use a calculator. And if I start with this number, I enter 2.30 is positive, right? And then you can't use the minus sign for this number on a calculator. You have to use what's called the negative button, and it's down at the bottom, because you can't say 230 minus that. That's not what we're looking for. You're 230 plus a negative 2.75. You're still going to come up with a similar number, but it's going to be positive if you do it my way. This number will. I'm not saying positive good. I'm just saying it's going to tell you that you're going to have a cut. But this is okay. This is the actual calculations that we did. We just had a positive number to deal with, to do it with. So this is, I think, where am I? This is the last slide. This is my homemade table over here. I'm quite proud of being able to get both these on here. I don't remember how I did it, but I did. So this is a practice in interpolating all these. These actually are. Uh, I looked at what they had, and I kept theirs because, again, the taking this node C5 right here, if they say it's 103.95 and there's 104, I can call it 103.95 as opposed to 104, because 103 is back up in here, and that's what they're interpolating off of. So it's almost 104. Uh, I used their calculations, and I did existing minus on, and these are different elevations than we were dealing with before too. So I think no, no, they're not. But I did mine existing minus this, and came up with this total right here, which is like theirs was 1.7, mine is theirs was negative, mine's positive 1.65, so that's close. And my uh, I may have changed some of these a little bit to suit me, but it's the same thing over and over. And that's all I got for you. Well, actually, it's evening here, and I'll have another video up talking about some more things, and by the time 7 gets rolling. And until then, I'm thinking we'll see you.